Okay, this last technique is a trick for being able to factor certain polynomials with four terms for which grouping fails. So sometimes we have a difference of squares in which one or both of the squares is, instead of a square monomial, a perfect square trinomial. So sometimes we have a difference of squares that has four terms because one of our squares is a square trinomial, the other is just a square monomial. So in this example, we have four terms: x to the fourth minus 10x to the third plus 25x squared plus 36. And we might try first to factor out a greatest common factor, but notice that this term has no coefficient. That is, its coefficient is 1. And this term has no variable factors. So there's no way that those two terms can have any factors in common. The first one has no numeric factors, the last one has no variable factors, and so our greatest common factor is just 1. That's not interesting. We don't need to do anything at that step, except confirm that we don't need to do anything. Okay, so I've got x to the fourth minus 10x squared plus 25x squared minus 36. And this has four terms, so my automatic go-to technique is going to be grouping. I'm going to set up a rectangle for factoring and just put my terms in descending order. So I've got x to the fourth minus 10x to the third plus 25x squared minus 36. So in my first row, I have greatest common factor x to the third. I'll need an x here, and I'll need a negative 10 here. X times what gives me 25x squared? So maybe 25x, but 25x times negative 10 is definitely not negative 36. So I can try factoring by grouping, but I see pretty quickly that grouping fails. Now, if this were quadratic, that would be the end of the game. But this is higher degree. And in particular, I notice that this x to the fourth minus 10x to the third plus 25x squared has its first and last terms perfect square monomials. So I think, hey, is this a perfect square? And I think, well, I've got an x squared squared. I've got a 5x squared. And then if I take negative 2 times x squared times 5x, that's negative 10 x to the third, which is exactly my middle term. Okay, so then I can rewrite this trinomial as x squared minus 5x squared minus 6 squared. So that gives me a strategy. I'm going to say that I have x squared minus 5x squared minus 6 squared. This is a difference of squares. I'll have x squared minus 5x minus 6 times x squared minus 5x plus 6. So simplifying this a little bit, I now have x squared minus 5x minus 6 times x squared minus 5x plus 6. I've just factored that polynomial with 4 terms as a product of 2 trinomials. And currently my only available strategy to make that happen is this difference of squares trick. Let's see if we can factor further. My first polynomial factor, I have x squared minus 5x minus 6. And let's see, that's actually a quadratic trinomial. The leading coefficient is 1, so I can use the shortcut. I need 2 numbers whose product is negative 6 and whose sum is negative 5. I think that's 1 and negative 6. So I'll have x plus 1, x minus 6. And I can multiply that out and double check that I really do get x squared minus 5x minus 6 from it. Okay, that's my first polynomial factor, fully factored. And of course, I know that these are prime because they're linear. Let's look at that next factor. We have x squared minus 5x plus 6. Those are similar, but remember, the sign on the last term means a lot when we factor a trinomial. Leading coefficient 1 again. I need 2 numbers that when I multiply them, I get positive 6. And when I add them, I get negative 5. Both of my numbers are going to be negative. And let's see, I think negative 2 plus negative 3 gives me negative 5. And again, those are both linear. So I know that they're prime. I've now factored my polynomial fully. So let's put it all together. We had no GCF. So our original polynomial, x to the 4th minus 10x to the 3rd plus 25x squared minus 36. That factored fully as x plus 1 times x minus 6 times x minus 2 times x minus 5. Okay, so this difference of squares trick, when can we do this? We're going to use this if we have 4 terms, grouping fails us, and we see that 3 of the terms in our polynomial are perfect squares. Let's see another example where this happens. So in this polynomial, we have x to the 4th minus 4x squared plus 12x minus 9. And again, we see coefficient 1 in the first term, no variable term in the last term. And so our greatest common factor is 1, so there's no work to do at that first step other than determining that there's no work to do. Next, we want to factor that polynomial. So again, we're going to try grouping, because we should always try grouping first when we have 4 terms. But I'm kind of pushing this off to the side because I don't think it's going to work. X to the 4th minus 4x squared plus 12x minus 9. Greatest common factor in my first row is an x squared, which means I'll have an x squared minus 4 across the top. And I already know that that's not going to work because negative 4 doesn't go into negative 9. Grouping fails us. But then we notice that x to the 4th is x squared squared. 4x squared is 2x squared. 9 is 3 squared. And this 12x, I think that 12x shows up somehow as 2 times 2x times 3. So something's going on with these three terms. But I notice the 4x squared and the 9 are both negative. What can I do about that? Well, I want to write this. I have currently x to the fourth plus negative 4x squared plus 12x minus 9. And I'd like to think of that as subtraction because I want to get a difference of squares. So I can say that this is x to the fourth minus the negation of negative 4x squared plus 12x minus 9. So that's x to the fourth minus, toggle all of the signs in the parentheses, positive 4x squared minus 12x plus 9. And now I see that this is a perfect square with a negative middle term. X to the fourth is x squared squared. I have x squared squared minus 2x minus 3 squared. Ooh, okay. Let's see how that factors then. Difference of squares, we'll have x squared minus 2x minus 3 times x squared plus 2x minus 3. And then simplifying, we'll have x squared minus 2x plus 3 times x squared plus 2x minus 3. Whew. So using the difference of squares trick, being super careful with my negative signs, I've gotten this 4-term polynomial of degree 4 factored as a product of 2 trinomials of degree 2 each. Let's see how those continue to factor. Well, the first one, I've got x squared minus 2x plus 3. I need two numbers that multiply to positive 3 and add up to negative 2. But I have 3 is negative 1 times negative 3. Negative 1 plus negative 3 is negative 4. And that's really it. That's the only way I can multiply two negative numbers and get positive 3. This one is prime because the AC method fails. How about the other one? My other trinomial factor, I have x squared plus 2x minus 3. Now I need two numbers that multiply to negative 3 and add up to positive 2. Well, negative 3 is positive 3 times negative 1, and 3 plus negative 1 is positive 2. My leading coefficient is 1, so the numbers that show up in the AC method are the numbers that show up in the factors. We'll have x plus 3 times x minus 1. And of course, these are linear, so they're prime. Now we've factored or determined whether they're prime each of those two quadratic trinomials we got. And so our original polynomial, which was x to the fourth minus 4x squared plus 12x minus 9, factors as a prime quadratic, x squared minus 2x plus 3, times two linear factors, x plus 3 times x minus 1. And all of those factors are prime, so this is fully factored.